everyone, in today's video we are learning how to clean data using Python's Pandas library. So in the last video in the series, we imported Pandas, we read in the dataset, and then we explored the data frame a little bit to find out more about it. All of this information is going to help inform what cleaning steps we need to perform. Now, just as a quick refresher, this is the dataset we're using. It contains information about job postings from LinkedIn, and we want to answer the following questions about data-related jobs. Now, before we apply any of the cleaning steps, let's make a copy of the postings data frame. The postings data frame is our original data frame, and it's the result of reading in our CSV file. Making a copy of the original data frame is a best practice that allows you to keep a version of the original data just in case you need to refer back to it. So to copy the data, we'll define a new data frame variable called postings cleaned, and we'll set that equal to postings.copy. This is the Pandas function that will make a copy of the postings data frame, and it'll return a new data frame with the same data, but it doesn't reference the original data frame. So any changes that we make to postings cleaned will only apply to postings cleaned, and postings will remain the same. So let's take a quick look at postings cleaned. You'll see that all the columns and the rows are the same as what was in postings. So as a first cleaning step, let's clean up some of the column names and their attributes. One thing we uncovered in the last video is that some of the column names can be more descriptive. For example, we can make title into job title, we can rename description to job description, and we can also change applies to num applicants. So we'll do this using the Pandas rename function. This is a function that takes a dictionary where the keys are the column names that you want to change, in our case applies, title, and description, and the values in the dictionary are what you want to rename the column to. So it would be things like job title, job description, and num applicants. So we can do postings underscore cleaned dot rename, and to rename, the first argument we'll give it is that dictionary. So we'll put in title as one of the keys, and the value that goes with this key is job title. And then the next item in our list will be description, and we want to rename that to job description. And finally, we'll have applies, and we want to rename that to num applicants. Now this function and several other Pandas functions also take two more arguments. The first is called axis, and this specifies if we want to rename these things in either the columns or the index. So if we want to rename it in the rows or the index, we would set this equal to 0, and that's what it defaults to. However, we want to change the column name. So where column name is title, change it to job title, not where the index value is title. So instead of 0, we'll set it to 1. That'll tell Pandas to look for these keys in the columns, not in the rows. This function also takes another argument called inPlace, and this specifies if we want to change the data frame that we are running the function on, in this case postings cleaned, or if we want to return a new data frame with the result of the function applied. So this is called inPlace because you are effectively saying if you want to change the existing data frame in its place or not. And in this case, we do. So we're going to set that equal to true. This does default to false. So if you don't specify this argument, running this function will actually return a new data frame, and the column names will not be changed in postings cleaned itself. And now we can look at the first few rows of postings cleaned. And you'll see now we have job title, job description, and num applicants. Next, let's clean up some of the column data types. Sometimes the data types of our columns can be incorrect when we first read them in from the CSV. In this data set, it's honestly not too bad, but you will see that there's some columns like zip code and FIPS that are coming in as float values. And zip code and FIPS, we want those to be strings because a lot of times both of those codes have leading zeros. So if you have a zip code like 02134, which I believe is the zip code for Boston, we read that in as a float or as like a number, it'll truncate that 0 and save it as 2134. So we want to save that as a string. The same thing for FIPS as well. So we can do this using the as type function. So we'll do postings underscore cleaned equals postings underscore clean dot as type. This function is similar to rename in that it takes a dictionary with the column name as the keys, but now the values are the new data type we want that column to have. So we'll specify zip code as one of the keys, and the value for that is str because we want it to be a string. We'll do the same thing for FIPS. Now the as type function does not have an in place parameter like the replace function had. So we have to make sure that when we run the as type function on postings cleaned, we have to reassign the result of running this function back to postings cleaned itself so that the data types actually get changed in postings cleaned. So we'll run this, and then we can look at our D types again. And you'll see that zip code and FIPS are now objects, which means they're strings. Now, I will mention you don't have to specify a dictionary for this function. You can also run this with just one column if you want. So you'd select the zip code column and you'd set that equal to calling the as type function on that column. So you'd select postings at zip code again, and then you do as type, and then you just specify the type that you want it to be, in our case, str. And you can run that, you'll see that runs correctly as well, and then when you print D types, it'll still be object. However, if you have multiple columns where you want to change the data type, running the as type function on the entire data frame and then passing it a dictionary containing the columns you want to change and the data types you want to change them to is generally an easier method. The next thing we uncovered in our data set is that some of the columns have a lot of missing values, specifically things like skills, description, median salary, and close time. Now, we don't really need these columns to answer the questions that we defined earlier, and since a lot of the values are missing, we can just drop out these columns from the data set entirely. And we can do that using Pandas drop method. So to do that, we'll take our postings clean data frame, and on that, we'll call the drop function. To drop, the first argument is either the column we want to drop or a list of columns we want to drop. We can drop each of those 3 columns one at a time by calling drop 3 different times, but instead it's easier to just pass a list of columns we want to drop. So we can do that where we will specify median salary, close time, and we'll specify skills description. Now this function also takes the axis and in place parameters. So for axis, we'll set that equal to 1 because we want to drop the columns with these names, not just the rows where these values are seen. And we'll set in place equal to true so that we don't have to reassign the data frame back to itself. So we can run that. And then when we run postings clean.columns, you'll see that these columns no longer exist in the data set. So if you look through this, you'll see we don't have median salary anymore, we don't have close time anymore, and we don't have skills description anymore. Next, let's look at how we can do some string cleaning on the columns that have a string data type using Pandas. One of the really common cleaning steps you'll do is text standardization, and this includes things like removing leading and trailing spaces from string values and either making the string values all uppercase or all lowercase, so you can count unique values of strings without worrying about their capitalization. So first, let's look at using the strip function to remove the leading and trailing spaces in a string column. So we can do this for job title. So we'll select the job title column, and to clean it, we'll select the job title column again. And on that, we'll use .str, and I'll get to what that is in a minute. And on that, we will call the strip function. Now let's take a step back and look at this code a little bit more closely. If you remember from the last video, when we select one column of a data frame, a series is returned. So here we're getting a series that is a string data type. Now .str here is what's known as an accessor. And what this accessor allows us to do is it allows us to run the string classes functions like strip or lower or split or anything like that on each element of a series that has a string data type, which is what this portion of the code is returning. So basically, when we do .str.strip, we're telling Pandas, hey, apply the strip function to each value in this series. So that's what it'll do when we run this line of code. The next thing we can do is we can just copy this same code and we can paste it again. But instead of calling the strip function, we'll call the string class's lower function. So it'll change every job title that's in the data frame to the lowercase version of that column value. So now here, you'll see when we print postings cleaned and we select the job title column, all of the job titles are now lowercase, and before they were camel case. So like the M and the C here would be uppercase. And this kind of standardizes the columns so that if you want to count unique values, marketing coordinator like this will be counted in the same group as marketing coordinator with different capitalization. Next, let's look at how to handle missing values. These are the NaN and null values that you see in the data frame. Now there's a few ways to deal with these, and which way you choose really depends on your use case. One thing you can do is you can drop the column entirely if you see that there's a lot of rows with missing values for those columns. And that's what we did earlier for our use case. We dropped out median salary, close times, and skills description because too many of those values were missing and we weren't really going to use those columns in our analysis anyway, so it was easiest to just drop them out. Now, one of the columns that has a lot of missing values, but is one that we might want to use, so we don't want to drop it out entirely, is the remote allowed column. You'll see out of 123,000 rows, only about 15,000 have a value for that. So when we look at the unique values of the remote allowed column, you'll see we get NaN, which is the missing value, and then we also get 1. You'll also see that this is 1.0, which means that it's treating remote allowed as a float, and we can change that to an integer later. But for right now, let's just focus on filling in this NaN value. Since the values are just NaN and 1, that kind of indicates that when remote isn't allowed, instead of adding like a 0 or like a not allowed value, they've just put in not a number. So we can fill in these NaNs with 0. So to do that, we will use the fillNA function. We'll run that just on the remote allowed column. So we'll do .fillNA. And the first argument to this is the value you want to fill in NaN values with. So in our case, that's 0. And this also takes the in place parameter, which we will set equal to true. So after we run that, when we look at the unique values of remote allowed, we'll see we now have 0 and 1. And while we're here, we'll also change the data type of this to integer as well. And now it's just 0 and 1 instead of 0, point, and 1 point. So dropping columns entirely if there's a lot of missing values, or filling in the missing values with a specified value are two ways to deal with missing values. Another way is to just drop the rows that have either missing values for all the columns or have missing values for specific columns. And we can do that using the drop_NA function. So first, let's look at how we would use that function to drop rows that have missing values for all of the columns in the data set. I'm not actually sure we have any like that, but we'll see. So we take postings.cleaned, and on that we would call the drop_NA function. And this function takes 3 arguments or parameters. The first is axis, which defaults to 0, which means that we're looking at the rows, but we can specify it here anyways. The next parameter or argument is called how, and that takes the values of either any or all. And what that specifies is if we want to drop rows where any column value is empty or where all column values are empty. So in this case, we want to drop rows where all column values are empty. And this function also takes the in-place parameter, which we will set to true. So we can run this, and we can check if that dropped anything by looking at the shape of the postings cleaned data frame. So it looks like it still has about 123,849 rows. And we can look at our original data set to see what the shape of that was. See, that's why it's a good thing we had a copy of our data set so we can refer to the original. Okay, and you'll see the number of rows is the same, which means there were no rows in this data set where every column value was empty. However, we can also run this drop_NA function with just a subset of columns. In that case, this drop_NA function will only look for empty values in that column. So one of the columns we can do that for is company name. If a company name isn't specified, we probably don't want that row there. So we'll take this code again, and we'll change some of these arguments here. We don't need the how parameter anymore, and instead we can use the subset parameter. Here we can specify a subset of columns where if there's an empty value for that column, we want to drop that row. So we'll specify just company name here for now. So I'll run this, and then we'll look at the shape of the data frame again. And remember, it has 123,849 rows initially, so if that drops, that means some of the columns were removed. All right, so here now we have 122,130 columns. So it looks like there were like 1.5 thousand or really almost 2,000 rows that did not have a company name. So those had a null or NaN value for company name, so those got dropped out of the data frame. Now, I will mention that dealing with missing values is a whole topic on its own, and I actually have a video about the types of missing values and kind of how you can deal with them, which I'll link up here if you're interested in diving a little deeper on that topic. Now, the last thing we'll cover today for data cleaning is checking for duplicated values. These are rows that have all the same values as another row. So you have 2 or more instances of the exact same data in your data set. Now, this data set actually doesn't have duplicates, but I'm adding some in just to show you kind of how to handle them using Pandas. So this is the code that does that. You don't have to worry about any of this right now. We'll actually go over the concat method in a few videos from now, but right now this is just here to add in some duplicates. All right, so now that we actually have duplicates added into our data frame, we can see them using the duplicated function. So once again, we'll take our postings clean data frame, and on that we will run the duplicated function. And when we run this, it's going to return to us a series of Boolean type where each value in this series is either a true or false value, indicating if that row is a duplicate. So here you can see the first few rows are not duplicates, but you'll see the last few rows are duplicates. And that's because that's where we added those duplicate columns. We added them to the end of the data frame. So all of these are duplicate values. They appear already somewhere else in the data frame. Now, if we actually want to see the content of the rows that are duplicated, we'll take this code and we'll actually select those rows, which we kind of do similar to column selection. We'll take our postings clean data frame, we'll have these square brackets, and in those square brackets, we'll put that code that gets us the duplicated rows. So when you run this, here you can see the duplicated rows. And you might notice here that none of these rows look like they're duplicated, like Corcoran, Sawyer, Smith doesn't appear anywhere again? Well, that is because you're only seeing one instance of the duplicated rows. So this duplicated function actually has a parameter called keep, and that specifies which occurrence of a duplicated row should be counted as the duplicated row. It takes the values of first, which treats every occurrence except the first one as a duplicate. You can also set this to last, which treats every occurrence except the last one as a duplicate. Or you can set this equal to false, which will treat every occurrence of a duplicate row as a duplicate. Now this defaults to first. So when you run this function without specifying keep, it defaults to first. So the first time a row occurs, it's not marked as a duplicate, but every subsequent time it is marked as a duplicate, and those are the rows that you're seeing here. So you'll see if we do keep equals false, we'll get every single time the row appears. So here you see that row for Corcoran Sawyer Smith with this job ID. You'll also see that down here again. To drop duplicates, we can use the drop duplicates function. So we'll take postings cleaned again, and on that we'll call drop duplicates. And this function takes optional parameters of subset where we can specify the columns where we want to search for duplicates. It's similar to the drop NA subset parameter where we only wanted to look for missing values in specific columns. And it also takes the in place parameter as well. Now in our case, we want to drop rows where every single column value for a row is duplicated, so we don't actually need to specify subset. By default, it'll look for rows where all column values are duplicated, but we do want to specify in place equal to true. So I'll run that, and if we take that code we had earlier where we wanted to see duplicated values, when we run that after doing drop duplicates, you'll see we don't get any rows returned because now we don't have any duplicated rows in the data frame. All right, so that is it for this video. Those are the most common functions used when cleaning data in Pandas. We went over renaming columns, changing the data types, manipulating string columns, dropping and replacing missing values, and dropping duplicates. So if you made it through this video, congratulations. That was a lot to handle, but hopefully you learned a bit more about these functions in Pandas and when they are used. In the next video, we will cover filtering the data and we'll talk more about indexes in data frames. Make sure you subscribe to the channel for that. Thank you so much for watching this video, and I hope to see you in the next Pandas video. See you there.